All right, these are the answers for review preview 5.1.2. First one, 8% of 150. Now, it wants you to multiply this. So I know 8% is 8 out of 100. And I'm going to times that by 150. And I know in order to multiply fractions in a whole number, I can write 150 out of 1. And when I do that, I get 1,200 out of 100. And then I know 100 goes into 1,200 12 whole times. So the answer for the first one is 12 wholes. The second one, 8.5. This one gets a little trickier because I'm going to leave it as 8.5 out of 100 because, again, a percent is always out of 100. Then I'm going to times that by 70 over 1 because I can write a whole number as a fraction that's over 1. And then I get 595 out of 100, which is the same as 5.95 or 9 95 100ths. Okay, because 100 goes into 595 5 times with 95 left over. That is the first question. Second question, really actually quite simple. A lot of words. Here's basically what it's asking you. Okay, this girl is making a model for the city council to look at, to approve, to see if they want to do it. So the first question says the council wants a model much smaller than what she originally made. So what is something you can multiply that by, that first model by, to get something smaller? Well, for example, let's just say the model is a rectangle and it's a, 10 by 4. Okay? I would use the example of I'm going to make everything 1/4 as big. So I would divide both those by 4 and it gets 4 times as small. So for my first one, I can do an example of 1/4. You could have any fraction, 1/8, 1/10, 1/12. As long as it makes the model smaller, that's the whole key. The second one, it wants to make it slightly larger. So the first one made it smaller. Second one is making it larger. So for an example, for number 2, I thought 3/2, which is the same as 1.5. So I'm going to make it 1.5 times larger. Or you could do anything as long as you're making it larger, such as 5/4, which is the same as 1 1/4. I'm making it 1 1/4 times larger. As long as your fraction makes it larger for the second one, you're fine. Lots of answers for this problem. Next one. I love this problem. Okay, this is kind of similar to one we did in class the other week. Billy was going to run 3/4 of his course, okay, and Ken was going to run 1/2. Again, it always helps me to underline what I know. Then it says Billy only finished 1/3 and Ken only finished 1/2 of his run. Remember, the whole course, the whole key here is of his run. So Billy was going to finish 1/3 of, remember, of means multiplication. His run was 3/4. When I multiply that, I multiply straight across. 1 times 3 is 3. 3 times 4 is 12. And I can simplify that to 1/4 because 3 goes into 3 one time and 3 goes into 12 4 times. As for Ken, he had 1/2 and he only ran half of that. So he only ran 1/4. So in turn, they both ran the same exact distance of 1/4. Next one. Ooh, I gotta erase some of these lines on here. Adding and subtracting fractions. Again, I'm going to only go over 2 of these. I'm going to choose to do 2 and 3. And you have to use what I go over in 2 and 3 to figure out 1 and 4. So number 2, 7/8 minus 1/2. As you remember, the whole key with adding and subtracting fractions is that you get a common denominator. You must have a common denominator. If not, you cannot add and subtract. So in this case, I should be thinking, what's a number that 2 and 8 both go into? And I know that 2 goes into 8 evenly. So I'm going to keep the 7/8 the same, And 1/2, I want that to be out of 8. I know I have to multiply 2 by 4 to get 8, so I have to do the same to the top. And remember, right here is that giant 1. I'm not going to make it look like a giant 1 right now, but that is our giant 1. So it's 4/8. And most of you probably know that one already. So then now I can just multiply the numerators. 7 minus 4 is 3. Denominators stay the same. Your answer for number 2 should be 3/8. For number 3, I'll do that one over here. First things first, must make it improper. Or I don't have to make it improper. In fact, with adding, I don't have to. But when you do the next one here, subtracting, I would highly recommend making it improper. So I'm going to show you that in number 3 here. 3 times. I did incorrectly real quick. I just realized this. That should be 20 twelfths plus 15 twelfths. Okay, because I don't know why I made it out of 20. It should be 35 twelfths. Excuse me for that correction. And then that is the same as 12 and 11 twelfths. Okay, I actually made a mistake on that one. Last one. I know when I multiply to find the area of a rectangle, I take the length times the width. So I multiply those together. So I know 100 times, in this case, x. And I'm not going to use the multiplication sign because that looks like 2 x's, and we don't want that. Times x equals 500. Well, I should know that 100 times 5 is 500. Next one, 8 times something is 64. I know 8 times 8 is 64. My next one, 5 times something, in this case r, is 82. Now this one I did not know. The other two I knew in my head. This one I had to figure out. So I had to figure out how many times 5 goes into 82. So basically I did a division problem in my head. I knew 5 goes into 8 one time. I'm going to minus 5 with 3 left over. Then I'm going to bring down the 2. And 5 goes into 32 6 times, which is 30, with 2 left over. So I know it's 16 and 2/5 for number 3. And then 4 goes back to a really easy one again. 5 times w is 25. That's equals 25, which means w has to be 5. There are the answers to review preview 5.2.1.